Alright, this recording is on polynomial long division. This first question says, which polynomial is 4x plus 3 a factor of? And you have four choices. What this question is really asking is if you divide 4x plus 3 into one of those four options, which one will give you a remainder of 0? And that means it's a factor of it if the remainder is 0. So all you want to do is, actually do the division. So you'd set the problem up like this. Let's say you're going to test, well, if I can find my mouse, there we go. If you're going to test this one, obviously you're going to want more room down here, so move these answers or, grab a piece of scratch paper and do this. But this is how you'd set it up. You'd put 4x plus 3 over on the left as a factor, and then you're just going to divide. Okay, and then when you get done dividing, you get a remainder of 0, then that means that's the answer you're going to pick, because if it's a factor, it's going to have a remainder of 0. So when a question says, what is it a factor of, it's really asking which one of these would give you a remainder of 0. So let's actually do some division, because I know that's probably your next question is, okay, well, how would I actually divide that? How do I figure out if my remainder is 0 or not? So let's try this problem. We are going to take t plus 2 and divide it into t squared minus 5t minus 14. Okay? So if you think about, regular division when you were back in, third grade, you would look at the first number on the outside, and then you would look at this first number on the inside, and you'd say, how many times does this number on the outside go into the number on the inside? Or what would I have to multiply this number by on the outside to get to this number on the inside? So it's the same idea with polynomials. I know it looks very weird, but once you do it and practice, 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 as in anything with math, then it will start to make sense. So let's try this one. You're going to say, okay, we have a t sitting right here. What would I multiply this t by to get to t squared? Well, if you take this t and you multiply it by another t times t is t squared, right? So that means up here I'm going to put t, and I'm going to take this amount that I put up here, whatever you put up here, and multiply it by this whole thing. Because remember, again, think back to regular number division. Whatever number you have up here, you multiply it by this whole entire thing. So it works the same way. We're going to take t and multiply it by t plus 2. So if you need to, you can do, you can either do it in your head or write it out over here if you need to. I know it's a little bit hard to do in your head, especially when you're first getting used to it. So you would distribute. We'd take t times t. That would give us t squared. And then we would take t times 2, which would give us plus 2t. And that is what's going to go underneath down here. So we're going to have t squared plus 2t. Okay, now let's again think about regular number division. What do you do? Oops, sorry, I didn't mean to add that extra line there. Let's delete that. What do you do with, well, I don't know if I can. Okay, this is supposed to be a t right there. Okay, what do you do with this amount down here? Well, what you would do is subtract, right? I know it's hard to think. When you're looking at this problem, you're just kind of overwhelmed at first, so it's hard to think back to an easier problem. But that's what you do with the stuff that you put down here. You're going to subtract. You're going to take this and you're going to subtract this. Well, rather than thinking of it as subtraction, what I like to just advise is just to change all the signs on all your terms, and you really are subtracting when you do that. But I think it's easier than writing a subtraction sign out here and then putting parentheses around this whole thing, because you want to subtract the whole thing. Just change the signs. So make this a minus and make this a minus. Okay, and then just and then add. Okay, so if you just change the signs, then that's already taking care of the subtraction part for you. And then you're just thinking like combining like terms. Change the signs, combine like terms. T squared minus t squared cancels out, and if you've done it correctly, that's always what should happen. Those first terms should always cancel out. Here you have a minus 5t, and you're combining it with a minus 2t. So that's going to give you minus 7t. Okay, so remember you're adding, change the signs, and then just you're thinking adding. So you're just combining those terms. So like terms means you add the coefficients out in front. Okay, let's think one more time back to simple division when it was just nice numbers, no letters, no polynomials. Remember the next thing is that you always bring the next number down. Same idea here. We don't have you do have a number, but yeah, I guess we're thinking of it like terms. So you're bringing the next term down, like so. Okay, and then you repeat the process. So you go back here and you say t, how would I get from this t to this minus 7t? What would I multiply this t by to get to a minus 7t? Well, you would take this t and you would multiply it by minus 7 or negative 7. And so that's what you're going to put up here. Okay, and then you repeat the process. So remember, you're going to take just this minus 7 and multiply it by this entire polynomial over here. Again, if you want to come over here and do some scratch work, you can. You're going to have minus 7 times t plus 2 would give you minus 7t minus 14 because you're distributing that minus 7. And that goes underneath minus 7t minus 14. Now hang on one second before you do the next thing. Go back up here, think about what we did. We changed the signs. So right after you get done multiplying and you put it underneath, change the signs. So instead of minus, I'm going to do plus, minus, plus. Change the signs. And then you're just combining like terms. So in other words, adding. Okay, so change the sign and add. You're really, you're doing the same thing as the subtraction, but it tends to be easier for students when you're working with polynomials to think of it as changing the sign and add. Okay, now I know traditionally when you're working with numbers and you're dividing, you just think subtract, but again, that was easier. That was just numbers, right? Now we're doing polynomials, so it's easier if you remember that one slight difference there, change the signs and add. And what's going to happen again here, it's what should always happen, is these first terms should cancel. I have a minus 7t plus 7t cancels out, right? Now here, that's conveniently what happens here as well. Minus 14 plus 14 cancels out, so here's my remainder of 0. Okay, and I'm done. There's nothing else to bring down. So if there's nothing else to bring down, you are done with the problem. Whatever is left is your remainder, in this case 0. And so I could say, just like on the last slide, t plus 7 is a factor of, or excuse me, t plus 2 is a factor of t squared minus 5t minus 14. And it's actually these two factors put together, if you FOIL them out, would equal the t squared minus 5t plus minus 14. So if you want to check your work, if it's a perfect factor, if you get that remainder of 0, and you took t plus 2 and you multiplied it by t minus 7, and you FOIL that out, first outer inner last, you're going to get t squared minus 5t minus 14. Okay, so if it's a factor, a perfect factor, you'll get a remainder of 0. That doesn't always happen, but in this case, since you got that remainder of 0, you would say t plus 2 is a factor of t squared minus 5t minus 14. Let's try another one. This one, I'm going to do another nice one. We're going to get a remainder of 0 here. And then we'll try one where it's not, and I will show you what to do. Alright, so we're going to do h minus 1 divided into h cubed minus 1. Okay? Alright, so we're going to start out the same way. We're going to look at this h out here, and we're going to say, what would I multiply this h by to get to h cubed? Well, we have 1h, h to the first power. If I multiply that by h squared, I'm going to get to this h cubed power. Okay, so I'm going to put h squared up here. And then remember, you take this amount and multiply it by the entire polynomial. So let's do some scratch work. We're going to get h squared times h minus 1. Distribute. We're going to get h cubed minus h squared. And that's going to go underneath here. So we're going to get h cubed minus h squared. Change the signs. Minus, plus, and then you're going to combine like terms, which should line up. Now look, h cubed and h cubed lines up, but uh-oh, look, there's a problem right here. Minus 1 plus h squared. Those are not like terms. You have to have an h squared and another term with an h squared in it in order to be like terms, right? So I did that on purpose because I want you to remember this one very important thing when you are doing long division with polynomials. If you look at the dividend here, you don't have all of the powers. We have h cubed as our highest power. We're missing an h squared and an h, right? This is minus 1 is like h to the 0. There's nothing there. So what you have to remember to do when you set up a problem is you want to put placeholders in there. So although I'm missing h squared, I'm going to put plus 0 h squared, just as my placeholder for that h squared position. Now keep in mind, I'm not changing the problem. I can do this because if I take 0 times h squared, I still get 0, right? So I'm just putting it there to hold a spot, but I'm not changing the problem. I'm going to do the same thing with the placeholder for h, so I'm going to put plus 0h, and then remember we had minus 1. Okay, so don't forget to do that when you write out the problem. If you just see like an h cubed and then minus 1, you say, uh-oh, I'm missing the h squared power and the h to the first power. I need to put 0 h squared, 0 h in there just to hold those positions. Because when you start multiplying, you're going to get h cubes or h squareds, and you need to be able to line those up and add correctly. It would just be like if you had a number, you know, that was supposed to have, I know it doesn't happen with numbers, so it's not a very good analogy, but you know, if you did have a tenths place, you want to add it to another spot in the tenths place, right? That's how we always line up decimals and add according to the place value. It's a similar idea with polynomials, except you're looking at powers. Okay, so just keep that in mind. Now I have everything lined up, and now I can go ahead and add. Okay, so I'm going to get h cubed minus h cubed, which cancels, and that's good. Remember, that's always what should happen. Otherwise, your number up here or your term up here is incorrect. Okay, 0h squared plus, remember there's really like a 1 out there, 1h squared leaves me with 1h squared, or just an h squared. Okay, now don't start multiplying just yet. Remember, bring down the next one. Okay, that's always how it works. So you got to bring down, I know it's 0h, but you still have to bring it down there just, you know, to hold that spot. Now we go over here and we say h times what would equal h squared? Well, h times h is h squared, so I put plus h. Now I'm going to take that and I'm going to multiply it by this entire polynomial out here. And again, you can do some scratch work over here if you want to. You don't have to do this part, but if you want to, especially as you get started, go ahead. Once you think you have it down, then just stop doing that part. Okay, I'm going to get h squared minus h. I change the signs, minus, plus, and then I add straight down to combine like terms. H squared minus h squared cancels out. 0h plus 1h is 1h. Okay, bring down the next term. Repeat the process. H times what would give me h? H times 1 gives me h. H times 1 gives me h. So plus 1. 1 times h is h. 1 times minus 1 is minus 1. I skipped my little scratch work over there, but please feel free to do it. If that didn't make sense, work it out over here like I did these other two, and you'll see it gives you h minus 1. Change the signs. Minus, plus, add straight down. H plus a minus h is 0. Minus 1 plus 1, 0. My remainder is 0, and I'm finished. Now, this is your answer, the part up here, right? Think back to regular division. That's your answer, is whatever is up top there. Now, one side note, usually what we try to do is to line up like terms. So really, the most correct way, I should have written this actually, to scoot all of these over to the right one spot so that the h squared is above the h squared in the dividend. You'll get the same answer either way, so it's not a huge deal, but just, you know, it is best to do it that way. So let's try it on this next problem. I'm going to do one more. And here we're going to have a remainder. So it's going to be the same process. There's going to be one extra step at the end, though. Actually, let me change my... I like to write it with a little bit thicker pen. Okay, so we have x plus 3. We're going to divide that into 2x cubed plus 5x squared minus 4x plus 5. Okay, let's double check and make sure we have a placeholder for all of our powers. So we have an x cubed term. The next is x squared, goes down by 1 power x, and then x to the 0, or you don't have a variable there, so that's x to the 0 power. So it looks good there. So double check that. Make sure you have whatever your highest degree is, that it goes down by 1. Otherwise, make sure you add in like 0x or 0x squared, or whatever you're missing. All right, now we are ready to start dividing. So I look at x and I ask myself, what times this x would get me to 2x cubed? So we're actually, just like I mentioned on that last problem, just to make sure that it's absolutely perfect here, we're going to actually put the answer above the x squared power, because to get from x to 2x cubed, I would multiply by 2x squared. So just remember, if I take this 2x squared and I multiply by x, that would give me 2x cubed. So because this x squared matches the x squared underneath, that's what I was talking about in the previous problem. That's the most correct way. You're supposed to line it up like that. It's, like I said, it's not a huge deal if you don't. But don't tell anyone I said that. Okay. So you can do some scratch work over here if you need to. We're going to take 2x squared and I'm going to multiply it by x plus 3. And you're going to distribute. So I'm going to get 2x squared plus 6x squared. And that's what's going to go underneath. So I'm going to have 2x cubed. Something was wrong there if I don't get the answer I'm looking for, right? Plus 6x squared. Change the signs. Minus, minus, add. Boom, those are gone. Positive 5x squared plus a negative 6x squared leaves me with a minus 1x squared. Bring the next one down. Minus 4x. So don't forget to bring the sign down with it. There's a minus sign right here. Bring that down. Okay. Start over. X times what would get me to minus 1x squared? Minus 1x. Okay, and then come over here and do your scratch work if need be. And remember, you're always multiplying the amount up here by the polynomial up front there to the left. So I'm going to multiply. I'm going to get minus 1x squared minus 3x. And that answer goes right here. So minus 1x squared minus 3x. And if you notice, when I do that, before I change my signs, these actually are supposed to match identically. Okay, and that way you'll be sure that they're going to cancel out. Okay, and so I got to change my signs. Change minuses to pluses and pluses to minuses. These are going to cancel. Minus 4x plus 3x gives me minus 1x. Bring the next term down. Plus 5. Start multiplying again. X times what would give me minus 1x? Minus 1 is all I have to multiply by there. So I'm going to do my scratch work over here. Minus 1 times x plus 3 would give me minus 1x minus 3. Remember, you're distributing there. Put that answer underneath. Minus 1x, and see how those minus 1x's match. So now when I change my signs and I add, they're going to cancel. Okay. Plus 5 plus 3 gives me 8. So notice I'm done because there's nothing else to bring down here. So I can't go any farther, but this isn't 0 this time. This is my remainder. So here's what your answer is going to look like. It's going to be this up here plus a little more. Okay, so remember on the last problem I told you if the remainder is 0, it's just your answer up here. Well, it is, now that we have a remainder, it's going to be that 2x squared minus 1x, or you can just write minus x minus 1. And here's how you write your remainder. You are going to take the whatever's underneath here, in this case just 8, you're going to put it over x plus 3, and you're going to make a fraction out of it. So it's plus 8 over x plus 3, and there is your ugly looking answer, but that is your answer. So we would say that x plus 3 is not a factor of 2x cubed plus 5x squared minus 4x plus 5 in this case, because our remainder did not come out to 0. But we can still get an answer of how we would multiply these two to get to that answer. But you wouldn't say just the vocabulary to watch out for. You wouldn't say it's a factor of it. You only say it's a factor if your remainder turns out to be 0. So I hope that helps. Let me know if you have questions. I'll talk to you guys later.